All right, so what's up to anyone who is just signing in here? Welcome to week 6. And I'm going to wait for the chat to get going here to answer any specific questions. Now, if there's anything, hang on a second, let me just log into my email. I'm just going to keep my email open so that anyone who's got something specific, if you don't want to just type it in the chat, you could email it to vinteachesmath@gmail.com and we'll throw it right here on the whiteboard. I'll just ask you to be patient because if I'm solving it, with one look at it, it's going to be a little bit tricky to, give the smoothest explanation, but I will do my best. So thanks for coming by, everyone who's here so far. So it looks like we have 4 viewers right now. So if you got any questions, just feel free to throw your questions in the chat. It usually takes a minute or two for the live stream to get really rolling here. So otherwise I could just pull up random math questions on my own and just, solve any math questions that I may want to work on. Let me just see here. I always have a spare calculus textbook on standby. Let's see here. Derivatives. What do we have here? Could pull up something random, otherwise just waiting for the chat. Once again, if anyone's got something specific, you just throw it in the chat. I could always warm up with the derivative here. So how about we do a derivative of maybe y equals, until someone takes over the chat and gives me something else to do. I don't want to just sit here and say nothing, so I'm going to throw this question in there. So let's see. So we've got this. All right. I do want to check one thing. All right. So here we go. Let's say I want to find the derivative of this function here. So we got our pen ready. For the chain rule, just know when you're taking the derivative with the chain rule that this is going to be the derivative, and let's move this over. Make space for this. So this could go over. Okay. So this would be the derivative of the outside function. Let's just fix that a bit. So the derivative of the outside function, we keep the inside function the same, but then we multiply by the derivative of the inside function. So for something like this, and I just want to make sure here the chat is currently working. If someone here wouldn't mind just typing something in the chat like hello, I just want to make sure it's actually functioning because it says we have 6 people here right now. But yeah, if any one of you would be so kind to just type something in the chat. All right, so let's see what we have here. So this one, my thought process here is we could use this formula or the phrase derivative of the outside. Then we keep the inside function the same. So we keep the inside function the same. And then we multiply by, so times the derivative, I'll abbreviate, of the inside. Okay, that's the idea. So then let me just stretch this out. Maybe I'm going to write hello to everybody. Hello. All right, so the chat seems to be working because mine is showing up. So I'm hoping people are able to type. Otherwise, I'm just going to get rolling here. All right. So let's say I want to take the derivative of this wacky function. I do the derivative of the outside, which in this case is sine. So I have cosine. I keep the inside the same. But now I multiply all of this by the derivative of the inside being sine of e to the x. Now, to do the derivative of sine e to the x, I'm once again using the chain rule. So I'm doing the derivative of the outside of sine of e to the x, which is sine, and that's going to give me cosine. I keep the inside as e to the x, but now we multiply by the inside function, the derivative of the inside function, and the derivative of the inside function is e to the x. So if we clean this up and put this in one phrase here, this would be cosine of sine of e to the x times cosine of e to the x times, and I can even just put the e to the x in front like this, and like that's okay. So that would be our derivative for this question. All right. Now, let's see. I want to see, can I edit? Hope this doesn't destroy the stream here. Let me just check something here. Customization. Oh yeah, the chat says live chat is on, live chat replay. All right. But yeah, once again, if we have anybody here right now, if you wouldn't mind typing in the chat, someone could be the first one to say something, just so I know the chat is definitely working, because a little bit quiet to start. Otherwise, I'm just going to solve random math questions of my choosing. So if no one has anything specific. Oh, we have something from someone for the live stream. So let's see. All right, let me check the email. So we have one from Marin Elise. So Marin Elise, is there any specific one that you want to see? Because I noticed I got a list here. You've got some volume of a solid type questions. So I don't know if there's any specific ones that you want to see, because we just have like a whole bunch here. I mean, I could just start talking about some of these. I could go in order, but if there's anything specific you'd like to see, you know what I'll do? Maybe let me just open this. I'm going to open up another YouTube link. I'm going to put my live stream on mute, but I want to see if maybe if I switch the view, if I'm getting activity. So just give me 1 minute to do this. So I'll make sure. Oh, all right. It says that I'm live. Oh, wow. Okay. The chat is very much rolling. So now I can see the chat from a different section here. 17 and 21 at Marin Elise. Oh, and Psycho Slayer, I see that you said Kenny is harassing you, so sorry about that. So I got emailed questions. All right, so 17 and 21. Let's take a look. Ooh, all right, 17 looks a bit nice. So, oh, and these are, I'll change the phrasing of them. I'm going to call it region S just for copyright purposes. But yeah, so region S we'll call it. Y equals, so this is question 17. Y equals e to the minus x, the x-axis. So this is our region. We have the y-axis. Then we have the line x equals b. And region S is the base of a... Oh, Cavalieri's principle. Wow. So at Marin Elise, you're already up to Cavalieri's principle. I'm like pretty impressed that they're that far ahead. That seems pretty like it's moving, you know, rather quickly. So yeah, maybe if I hopefully if I refresh this page, this won't boot the whole thing. Let me just see something. Don't boot everything. All right, I'm just refreshing this page. Oh, wow. All right, so I refreshed my stream page, and now everything is rolling just fine. All right, now we're in business. So, okay, no, now I feel very much way more comfortable. All right, so 17. And let's see what the question is. Region R. or region, I'm going to call it region S, just so it's a different question. So e to the negative x looks like this. That's e to the negative x. The x-axis is this, the y-axis, and the line x equals b. So x equals b is going to be positive because all the answer choices are positive. So yeah, let's see. This is all right. So this is how these Cavalieri questions work. Like this is your region S, is the space here. Like that's the boundary. And the actual solid itself, like this region here is the bottom of a solid. And the cross sections perpendicular to the x-axis are squares. So these are kind of tricky to imagine, but what I imagine is, let's say you take this region S and you kind of lie it on the floor here. Let me make that a little neater. These are like very tricky to draw. So yeah, it's like kind of like this. And then all of these cross sections, you're building them into squares. So you see like the squares here are not as big as the squares that are closer to the y-axis because this part of the function goes higher up. So whatever this solid is, that's what we're finding the volume of. So with Cavalieri's principle, the concept is area of the base times the height. Okay, that's the idea. So for something like this, what I do is I describe the volume of one cross section. The idea with these questions is if you could describe the volume of one cross section, like one of these slices, you could find the volume of the whole thing. The integral helps you find the volume of the whole thing. So if I draw one of them on the side, what is the dimensions of this square? Well, since this function is e to the minus x, see this is like a graph of e to the minus x here, then the height of this thing is e to the minus x. But since it's a square, everything's e to the minus x. And then the thickness of one of these, it's kind of like a Riemann sum concept, that the thickness of one of these things is just dx. These are supposed to be like infinitesimal, like super, super thin. So now that we have all this, the volume of one slice I call dv is, we're finding the volume of a square prism. So it's like base times height, like times depth, or like length times width times height. And I would do e to the minus x times itself, so it would be squared, and then times dx, which when you raise an exponent to an exponent, this is going to be e to the minus 2x dx like this. All right, so that's the volume of one slice. But since this is going from 0 to b, the volume of the whole thing would be the integral from 0 to b of, and we would have e to the minus 2x dx like this. All right, so that's just setting this up. Now I'm going to read the question more, and let's see. It's telling us the volume of the solid is 4/9. So if the volume is 4/9, let me just throw that over here. Okay, this is 4/9. Then what is the value of b? So now we just have to do the fundamental theorem of calculus part 1 on the other side. So I got to add a page since we're running out of space. All right, and come back here. So now I'm going to leave the 4/9 alone, but on the right side, the antiderivative of e to the minus 2x, just know the antiderivative of e to a constant times x is 1 over the constant, e to the constant times x, and then plus c if it was indefinite, but this is a definite integral. So this, I would say here, is -1/2 e to the minus 2x. I could write plus c, but it's a definite integral, so it's not necessary. And then from 0 to b. So then here, this is going to be 4/9 equals -1/2, and you're going to have e to the minus 2b minus e to the 0. You know, anytime I have a negative in front of my term that I'm plugging in like the upper lower limit for, I like to write the constant on the outside so there's less signs to lose track of. So now e to the 0 is 1. So this is going to be 4/9 equals -1/2. And we have, there's a few ways we could go forward with this. Honestly, at this step, what I would probably do, because I'm just thinking out loud, because these questions, the algebra gets a little tricky. I would multiply this entire equation by -2, because that's going to get the -1/2 to cancel. And then that's going to give us negative 8/9 equals, and we'd have e to the minus 2b minus 1. And then we could add 1 to both sides. And that's the same thing as 9/9. So I'll bring this over here. So this is going to be 1/9 equals e to the minus 2b. And then you could take the natural log of both sides. So this looks like we're going to have natural log of 1/9 equals natural log of e to the negative 2b. And then natural log and e cancel. So this is going to make natural log of 1/9 equals negative 2b like this. And then from here, we divide both sides by negative 2. So negative 1/2 ln of 1/9 equals b. All right, let's see. Does that show up? Oh, I see it. All right. So little algebra. 1/9. So side note. 1/9 is the same thing as 9 to the negative 1. So this is negative 1/2 natural log 9 to the negative 1 equals b. And the negative 1 pops out to make this like positive 1/2 natural log 9 equals b. All right. So I'm pretty sure that's the way to go here. Is that? Oh, let's see. My teacher did not do the units all in order. Oh, okay. So I was going to say that's like pretty impressive progress. No, I'm always interested to see what everyone's pacing is like and what they want to cover first. So I'm pretty sure that's right. I mean, like I said, when I'm solving these questions live, seeing them for the first time, you know, and you're usually going to bring me the craziest questions. Like, I'll do my best. I hope that cleared it up. All right, so 21. Let's see here. Oof. All right, yeah, these are rough. These are like marathon questions. They take a while. All right, let's see. And then I'll move on to the next set of questions. So this time we have y equals sine x, the x-axis, the line x equals 1, and we want to know which of the following gives us the volume of the solid when r is revolved about x equals 1. All right, for the first order of business is what is their actual region. So I always try to sketch this nice first. So sine x looks like this. So we have sine x, we have, and maybe I'll do this in a different color. So we have, let's go orange. All right, so we have sine x, we have the x-axis, and we have the vertical line x equals 1. Now, right away what I'm thinking is how like pi is roughly 3.14. Pi over 2 is like roughly like 1.57. So basically the line x equals 1, like if this is pi over 2, the line x equals 1 is like to the left of that, is like this. So this is the region that we're spinning. All right, that's the region you're going to spin. And you're spinning it around this line, x equals 1. So for this, the problem is we're spinning around a vertical line now. And anytime you spin around a vertical line, at least in the new curriculum, in the old curriculum, you could use something called the shell method. But all the revolution questions involve the washer or the disk. Now, since this region is flush against the line x equals 1, it's like on the line, we're going to use the disk. There is no space. So I take this region and I spin it like this, and it's going to make a disk. Okay, so it's going to look like this. Now, the problem with this, though, is that in order to go this way, what we need is we need a function to describe that horizontal distance. Because notice, like, this horizontal distance is bigger than this one. This one, like, they're shrinking. Okay, so whatever this solid is, it's going to look, I don't know, it's kind of like hard to describe what this would look like. It's almost like a, I don't know, like some sort of, like, almost like a, kind of like a, not a cylinder, like a dome of some kind. I don't know, maybe like a bird cage, kind of. That's what I'm imagining this solid is. But the way we're finding the volume of it is we're doing horizontal disks like this, and we're adding up the volume of all of these disks, like these thin ones. But now, what I always teach my students to make it hopefully as easy as possible is I think like, all right, if 8 was here and 6 is here, these are 2 units away. So the concept for vertical distance, I think top minus bottom. I say, oh, all right, 8 minus 6 equals 2. But if it was horizontal distance, then I'm doing right minus left, and I'd have 8 minus 6. All right, that's the idea. So this is horizontal distance. So it's the thing on the right minus the thing on the left. But the problem here is that with horizontal distance, with right minus left, we need equations in the form x equals a function of y, okay, for right and left. Top and bottom, this, you would have something in the form y equals f of x. All right, so it's a different idea. This one is trickier, the right minus left stuff. So here, what would be the equation in terms of x? If y equals sine x, then x equals, I'm going to use arc sine of y. All right, just know this is the same thing as like sine inverse of y, but the notation used here is arc sine. So the thing on the right, so when we describe one of these cross sections here, well, for one, the volume of one cross section is pi times the radius squared times dy, because now we have this like slight vertical adjustment here. So now the task becomes describing the radius of one of these. And to describe the radius, we do right minus left. So the equation on the right, our radius, the equation on the right is x equals 1 minus the equation on the left, this piece, is determined by the sine curve, but in terms of x, it's x equals arc sine of y. Now, from here, what you're going to do is you're going to say dv equals pi times 1 minus arc sine y, and that's being squared, and then times dy like this. All right, but now we need boundaries for this. Well, let's go into the x-axis. So at the x-axis, that's a low point of y equals 0. And then here, well, what we have to know for this, we have to know this is when x equals 1. And when x is equal to 1, what is y equal to? Well, we have this equation here. When x is equal to 1, y is equal to sine of 1, whatever that may be. Okay, so that's going to help us find our limits of integration. So we go from the bottom all the way to the top. So the volume is equal to pi times the low point is 0, y equals 0, and the high point for y is sine of 1. And then we're going to have 1 minus arc sine of y squared dy. And this question, the hard part is just setting this thing up. All right, but yeah, here I would say that this is going to be your solution. All right, so cool. All right, moving on here. I'm glad hopefully it made sense. To the people from my class watching, sorry if that was traumatizing, but you get a glimpse of what your future is going to hold. That's a hard topic. I would say from calculus AB students and BC students, volume of revolution is like one of the hardest topics. It's like very abstract. Even me, like right there, I was going slow. It's very easy to like make a minor mistake, and there's always an answer choice waiting if you make a minor mistake. So, cool. All right. Let's see. Is there other questions? But so far, yeah. To anyone here, just hello. And thanks for stopping by to week 6. So I'm just happy we were able to do 6 weeks in a row with no, no distractions or nothing getting in the way of it. So thank you all for coming too. I appreciate the regular crew here. Oh no, it's all right. It's good for them. It's like a sneak preview of what's to come. So don't worry. Yeah, to my students, like when I'm teaching this from the beginning, I'm I have like a lot of metaphors that I use for this topic to make it not so bad. For my students, their homework is always to go to like Boston Market or Costco or somewhere where they have rotisserie chickens so they could watch the chickens spin, because you have to know what it means to spin things. So just stay tuned. Trauma, I know, sorry, Xiaolong. It's, yeah, there's a lot of traumatic topics in calculus, but you all have each other to commiserate with. So, yeah, there we go. Hey, students from different schools, you're all connecting, so that's good. But you get through it. You know, I would tell you, even your calculus teacher, you know, I struggled with this at one point. And believe me, on certain days, if I get a weird problem, like I'll still struggle. I got to sit there and figure it out. You know, like the ones I just did. Sometimes, yeah, chicken trap. There we go. I like, we're already getting ideas. But, you know, like one of these, if I do 100 Cavalieri questions or revolution, not only would it take me like a long time, but, you know, I would mess one up here and there, and I'd have to go back and be like, oh yeah, I did this and I should have done that. So it's just a lot of practice. You know, that's the secret. This topic though, especially, the trick to getting good at this one, so at Marin, Elise, and anyone else here that is going to be learning this by, you know, a certain point, I would say is you have to understand the concept of like why the technique works. So it's like a combination of, yeah, Cavalieri's principle is big, but you really got to know your geometry. Like that's the idea. It's like you have to know what a cylinder is, like, and a thin cylinder too. Like it's got to be like a thin cylinder. And because I know the geometry, that's how I'm able to do this, like from memory too. Like like that question just jarred my memory. I haven't done one of these since like last May when I was getting my last year's students ready for the AP test. You know, I haven't had to do a Cavalieri or a revolution question in, how many months is that now? Like 5 months. But it's on retainer because I know why it works. So that's my theme always, is understand why it works, and you're way less likely to forget it. So, and not only are you less likely to forget it, but you'll be more accurate when you're doing this stuff. So, anybody else? So, Psycho Slayer, I see Kenny was verbally harassing you in a video game or something. Yeah, I know trash talking is part of video games, so I don't know, it's tough. You can always hit the mute button. When I play chess, I mute it sometimes because I don't necessarily want to hear my opponent trash talking me. All right, cool. Oh, hello to Alyssa, last year's crew. Let's see, email. Is this, what class are you doing right now? It's calculus. The derivative x plus 4 over x minus 4 to the third. Okay. And, oof. Oh, that looks like an implicit 8x squared. All right. I think it's asking me if I want to translate it. Do you want to translate it to Spanish? Like, no. I want to, like, maybe one day learn a little language. It takes practice. I mean, it's like 15 minutes a day. In 10 years, it'll get you there. All right, so 8. So, Alyssa, is this 8x squared times y and then plus 4xy equals 5x plus y? I hope, and you're calculating the derivative, dy dx. I'm hoping that's right. So I have your email now. So I'll start finding the derivative of this. If this is not what you want, just say like, oh no, that's not what I wanted. But this is implicit, which would have been like, 1 year ago. And it was a long time ago. So you got to do product rule here. And, if you're doing this in your head, the product rule, that's great. 4x to the third. Oh, okay. Let me just, it was 4x to the third times y. All right. So let me fix that. 4x to the third. Okay, so hopefully that is all good now. All right, now for this, I'm doing product rule, and this is like our first u term, that's 8x squared. And then our derivative of our u term is 16x. Our first v term is y, and the derivative of our v term here is dy dx. Okay, and then like maybe like in the same thought, like we're doing product rule again, but this is like our second u term is 4x to the third. And then our second v term is also y, and then that's going to tell us this is 12x squared, and then this one is dy dx. All right, so if you could do product rule in your head, great. Otherwise, like, you know, write it out like this. Now you're going to have 8x squared dy dx. And oh, and Alyssa, also, how's your brother doing? How's Ivan doing? Hope he's doing all right. I know he was like going to like England or something. All right, so we have this plus, and then we've got 12x squared y plus we have 4x to the third, and then dy dx equals, and then the right side, the derivative is 5 plus dy dx. So your goal is to get all the dy dx terms together. Like you need these three things together, and then everything else belongs together. So, you know, you do a little bit of algebra. I would subtract the 5. Oh, he's loving England. Great. I'm happy to hear. Yeah, maybe one week we'll have him on here too. You know, I'm sure he'll probably want to talk MMA or something, but, you know, it was nice having you both very different people, but like, that's like the cool thing too about, you know, having two kids of my own. It's just how different they are already. So, all right, so 16xy plus 12x squared y, and then minus 5 equals, and then we have dy dx, and you could do minus 8x squared dy dx, and minus 4x to the third dy dx. All right, so this is just algebra at this step. Subtract, and then we move, like these three terms belong together. The non-dy dx terms belong together. So then on the right side, I would factor out dy dx and have 1 minus 8x squared minus 4x to the third. And on the other side, I just leave it alone. All right, it's like this, just the same stuff. So just rewrite it. And then last step is to just divide. So we would have here our final answer, dy dx equals this side divided by that factor. So 16xy, plus 12x squared y minus 5 over 1 minus 8x squared minus 4x to the third. All right. So that should be it. The only way it could look different is like maybe the top and bottom is multiplied by -1, or the order of some of the terms might be swapped. That's about it. But implicit differentiation. And we got a different email with this one. Was it x plus 4? Oh, so that's like quotient rule, chain rule next. So the next question was, if we have x plus 4 over x minus 4 to the third, like take the derivative of this. All right, so chain rule. Remember, chain rule is life. Don't forget chain rule. So here you do the derivative of the outside, which is power rule. Okay, keep the inside the same. And then the derivative of the inside, we need to know quotient rule. So the quotient rule is this one. So we multiply by the derivative of the inside, but the derivative, once again, the derivative of the inside requires quotient rule. So we got the bottom function times the derivative of the top minus the top function times the derivative of the bottom, which is also 1. So I could just write, yeah, like a times 1 here. and then this is over x minus 4 squared. So then this is going to be equal to, we'd have 3 times x plus 4 over x minus 4 squared. And then if we simplify this, let's see, that's going to be x minus 4 minus x minus 4. You have to distribute the negative. That's like a little bear trap to avoid. And then let's see, this, if they want it like nice and simplified, like, you know, they're like, they want you to actually do algebra, then I'm seeing this is going to be like, all right, 3 times same thing. And then this is going to be negative 4 minus 4 is negative 8 over x minus 4 squared. And now you could multiply the 3 times the negative 8, which will make negative 24. And then you've got x plus 4. This you could separate to x plus 4 squared over x minus 4 squared. But then when you do x minus 4 squared times x minus 4 squared, that's going to give you x minus 4 to the 4th. So this looks like the derivative in like nice simplified form. Okay. But if simplifying doesn't matter, but I think in university they care. For the AP test, we're laughing about that today a bit in class, that you could like just leave 12 as like 5 plus 5 plus 2 and no one's going to care. But yeah, that will do it for that question. So next, any topics people would like to see? Let's wait to see what people have to say. Oh, happy to help. I hope I didn't mess up. I mean, you could always Wolfram Alpha to make sure I did it right, but I'm guessing the work counts. But thanks for the question too. Simplify all the way. Yeah, that's why I made sure to go that extra step. So in the chat, oh, we have 7 concurrent viewers, 40 people stopped by so far, so very cool. Yeah, I could go over the free response. If you have a question you want to email though, you can I'm more than happy to take a look at it. Because I may not be able to go over every single question on the whole thing. So if there's something specific you want to see, you could take a picture of your test question and send it, and I'm happy to look at it. So let me look in the email. Did I get any? All right, nothing new just yet. All right, it's 9:06. So we got about 24 minutes to go on the stream here. So let's see. Anyone else in the chat, you're welcome to type in a topic. Let me just read some of these. Did I miss anything? Oh, more just like hello from people. Well, I'm glad the chat came back. I was thinking like also if it ever gets quiet, like maybe down the line I could relearn some of my old math. Like I could relearn Calc 3. Because I think it would be really cool if my BC students, like when they graduate and they go on to Calc 3, if I could like still help them with like their new stuff. But I mean, it's going to be hard for me because I'm going to have to like actually go back into like heavy student mode. Not that you ever stop learning, but I'd have to really, kind of buckle down and practice a lot. And yeah, so let's see. Anything specific from anybody? All right, nothing just yet. I could find a random math question because it is a math live stream, so I will pick one out then to talk about. All right, I feel like I did one like this last week. Let's see, maybe 1994. Oh, that I actually have a video on. I think I did that question like in an actual video. Ooh, related rates. That's the other thing. We're gonna learn related rates kind of soon. That's one of those heartbreaking topics. That one. Oh, here's a nice one. How about, unless we have something specific, I'll check once more. All right, no one has anything specific. So we want to find here this question, the tangent to the curve. And I need to advertise this stream. I think I want to advertise it in like Reddit's AP Calculus, like that subreddit, or maybe even AP Student. Because yeah, I think that's the next step, is I have to advertise this more. Like, it was cool that I was able to get people from other high schools to stop by. But I think if it caught on that there's like weekly AP Calculus help, I mean obviously like weekly high school math help, I think people will be more interested in like having specific questions answered instead of like just trying to like find like their random needs satisfied from a random YouTube video on a topic. So I like to be able to answer specific stuff. And like, it's fun for me too to try to answer it live without any preparation. It keeps me sharp. So the tangent to the curve, this is horizontal when x equals blank. All right. So here, thought process, if you have some curve, the tangent is horizontal when the slope is 0. And the slope is the derivative of the function. So here, this looks like we're using product rule again. So here, we're going to have u prime equals 2, v prime equals minus e to the minus x. So then y prime is going to equal 2e to the minus x plus, actually I'm just going to go ahead and say minus because we're doing 2x times a negative. So minus 2x e to the minus x. And this I would factor. Take out an e to the minus x and take a 2 with it. They both have a common factor of 2. And you're going to have 1 minus, looks like you're going to have 1 minus x. Now, for this, we want to find out when is the slope equal to 0. So from here, y prime is equal to 0 when 2e to the minus x times 1 minus x equals 0. This is always positive. So that's not going to give us a root. E to the minus x looks like this. All right, so if I multiply it by 2, that means like it's going to go through 0, 2 like this. So that would be kind of like a graph of 2e to the minus x. So we're not going to get a root from that, but this one is going to give us a 0 when x is equal to 1. So that's when our slope is 0 at x equals 1. All right, so yeah, with our derivative, sometimes we're going to have to do the combination of setting our derivative equal to 0. But this is a nice question because it's got product rule, chain rule, and a bunch of algebra at the end. So cool. Let me check the chat. Anything new pop up here? Oh, hello to Lofi. I'm glad you stopped by. If you got any specific questions, Lofi, more than happy to answer. I see. Okay, the email. So, oh yeah, part C. A lot of people are going to have a question on part C. So let me pull that question up. So this is our equation. So x to the third plus y to the third minus 9xy is equal to 0. All right. So first order of business is to calculate the derivative. Part C on the test, I think I said, for which value of x is the tangent line horizontal? So same idea as the last question, is you have a curve and you want to know when is the slope 0, so you need dy dx. You're setting dy dx equal to 0. So first order of business, though, is taking the derivative of this thing. Okay, so that's the first thing you had to do, is take a derivative. All right, let me just make sure I'm copying down the correct question. Otherwise, that'll change things. So this would be 3x squared plus 3y squared dy dx. And then this is the first part you got to be careful. A common mistake with students with this one is they did something like minus 9y plus 9 x dy dx. So you just have to be careful here that you're going to have a double negative. All right, so you can say u equals minus 9x and v equals y. And then u prime is minus 9 and v prime is dy dx. So when we apply the product rule here, we're going to have minus 9y. We're going to have minus 9x dy dx. It's very important that both of those are minuses here. That was the first trap that people stepped in. And I've known that trap for like so many years. I would say like the first full year I taught AP Calc. I remember like one girl specifically like complaining about that trap. It was like, oh, that was like so cruel. Because like the question had like a double bear trap in it. So it's just like etched in my memory. So now what I would do is keep these together and I would move this stuff to the other side. So what we have is, and I'm going to factor out, we're going to have dy dx times 3y squared minus 9x. So you see the dy dx terms have coefficients of 3y squared and minus 9x. But then we add 9y to the right side and we subtract 3x squared on the other side. So then what you're going to get from here is that dy dx equals 9y minus 3x squared over 3y squared minus 9x. And then you divide all of those by 3. You're going to get 3y minus x squared over, divide by 3, you get y squared, and divide this by 3, you get minus 3x. So just simplify. Just makes life easier. And yeah, at Xiaolong, it looks like you did that too on yours. So like you got that part right. But now for part C, like once we have dy dx, dy dx is equal to 0 when the numerator 3y, whoops, let me say it like this. When the numerator 3y minus x squared equals 0. Because just know a fraction is only equal to 0 when the numerator is 0 and the denominator is non-zero. Okay, so that's very important, which this algebraically tells us 3y is going to equal x squared and that y is going to equal x squared over 3. Okay, so this is a big detail because then what you do with this is you're going to take the original equation. So let me borrow this. All right, and you're going to do solving this system by substitution. So you're going to have x to the third plus, now instead of y to the third, it's going to be x squared over 3 to the third power. And then we're going to have minus 9x times y is x squared over 3 equals 0. Now we just work this out. This is going to be x to the third, and we're going to have plus, this is going to give us x to the 6 over, and we're going to have 27, and then this is going to give us minus 9 over 3 becomes 3, so we're going to have minus 3x to the third equals 0. And then from here, x to the third minus 3x to the third is going to give you, that's going to give you minus 2x to the third. So you're going to have x to the 6 over 27 minus 2x to the third is equal to 0. Now, what we gather from this is we have to also think about in this question that when x equals 0, let's just see one thing here. We can't say the point 0, 0. The reason being that the condition was that for a fraction to equal 0, the numerator is 0, the denominator is non-zero. So if you look at our derivative, where's our derivative? Here. If x and y are both 0, your denominator is going to be 0, and this is going to be undefined. So we need the numerator to be 0, denominator to be non-zero. So we're going to kind of ignore the case where x and y are both 0. But if we take out an x to the third here, we're going to have x to the third over 27 minus 2 in this factor. So when we set this one equal to 0, this is going to give us x to the third over 27 equals 2. And then this gives us x to the third is equal to 54. So then x is equal to, and we have the cube root of 54 like this. Okay, I believe that was all there was to it. Let me just double check, because at the end of the day, my brain is totally fried, and it is very possible that I, could have said 5 plus 5 is 12 somewhere. Let me just double check that I didn't. So let's see. All right, that was, let me just see if this one has, oh yeah, this is just loading. I could just look up the, all right. And okay, yeah, this is correct. Cool. All right, so that was the idea. Not an easy question. All right, cool. That is part C. But thank you, Xiaolong, because when I have to explain that again tomorrow, I will have explained it once here. So I will be so smooth. I'm going to make it sound so easy. I'll be like, obviously, duh, that's what you do. But yeah, so this was rehearsal for tomorrow. All right, any other questions? Let's see. Looks like so far nothing new. All right, I could switch over to Q&A mode. If you got, study questions, general questions like that, I could put a cap on, the math stuff for now. Let me just do this. I'll turn off the this one, and I'm going to move this over here. So let me shrink this down. I'm glad no questions tonight required the use of a calculator either. That makes it easier. All right, so I will switch to, let's see, the fires. Yeah, like the fireside chat here. Oh, let me fix this. So this, I have to get better at like just changing, and then like it's just good to go. So let me see here. If I pop out the chat, I believe, does it? Oh, it's working. Kind of. All right, let me see. Window capture. Oh, here we go. All right. Like if I like bring one up, like, all right, cool. So it's working. So let's see. Your English is good. I am practicing. Oh, very nice. I appreciate the compliment. I mean, for me, I was, born and raised in New York. So yeah, I've lived here my whole life. And I even went to college in New York. So I've been here for, am I 34 and like a half now? So that's 34 and a half years of, well, minus, I don't know when I started talking, how old I was. I think I was a little older. But yeah. So thank you. Let's see. Oh, I have a question for the Delta Math. Let's see. So if you go back. All right. I mean, you could just throw a general question my way, and I will answer it. But let's see. Anyone else study questions or questions of, I don't know, any sort there that would like me to answer? We have 7 viewers still. So let's see, because I got about 5-ish minutes or 8 minutes to be precise. So I have a question for the Delta Math. It's so fun being able to bring the Q&A right in the stream here. So I'm excited. There's so many extensions to download to get good at. All right, let's see. Oh, this got chopped. How sad. Let's see. Oh no, I'm like moving my whole fireplace. People are going to realize my fireplace doesn't really exist. All right. So f prime has an inflection point, blah, blah, blah. All right, let's see here. It has a certain x points. Well, if there's no change in slope, like if you have a constant rate of change, like a line technically doesn't have a point of inflection. But, oh, it says f prime. Wait, if it says that f prime has an inflection point, I'd have to see the actual question. Yeah, I'd have to see like an exact question to know exactly. Inflection points represent when the concavity changes. So you're looking for a sign change in the second derivative of the function. So like something like x to the third, the second derivative of x to the third would be 6x. And 6x as a function changes signs at x equals 0. So x equals 0 is a point of inflection for x to the third. So like if I draw it on the screen here like this, like x to the third starts off frowning, concave down, and then it becomes concave up. All right, so yeah, second derivative sign change. Inferences from f prime or f double prime. Well, what we need the most with those, so at Tommy, is you have to make sign charts for f prime and f double prime. So using the test points on each interval, that will like help you make the sign charts. And then like you could say things like if f prime is positive on a specific interval, then your function f of x is increasing on that interval. If you have f prime is negative on a specific interval, then f of x is decreasing. If we have a sign change from plus to minus in f prime, that's a local max. Sign change from minus to plus on f prime would mean a local minimum of f of x. Okay, so yeah, that's more, theory to know. Your second derivative sign chart will tell you concavity. Second derivative positive tells you concave up, and a negative second derivative will tell you concave down. But yeah, in class time, I could look at specific questions. I don't know if I will pull up like more math questions just now, but I can give like general tips on how to handle them and stuff. All right, let's see. Oh, you're welcome. So, but there's, let's see, no equation. So how do we make sign charts? Well, if you don't have an actual equation, they have to give you more information then. So like what they might do is give you like, if they don't give you an equation, they have to give you like a table of values of some sort. And then from there, at certain x points, yeah, they would have to give you a table of values to work with. But yeah, at Xiaolong, I could, in class, ask me specifically like which question it is you want to see. And, I'll be happy to, you're always welcome to bring questions to class. It's not like always like, all right, we're going to learn exactly what I want to do. Like I could always carve out like a few minutes in the beginning or at the end to go over specific questions. All right. Or during practice, just say like, hey, can you also help me with this? And I'm happy to help. All right, let's see. Any others? How many people we got right now? Oh, we still have 6. Yeah, this stream got, last year, the most insane it was I streamed the day before the geometry regions. And I think then, like, I had, like, maybe, like, I want to say like I had close to, like, 100 people, maybe more, like, all at, like, once. But there was, like, maybe, like, 600 people that stopped by, 600 to 800, let's say, like, within, like, the actual stream, like, filtering in and out. So this will be fun as it gains in popularity. I really do appreciate, those of you that stop by and who have come to a few of these, showing the support. It really does mean a lot. This is like a fun part of my week. I really do look forward to doing these. So, thank you, for anyone who brought questions, and people who had comments or just, came to hang out and support the live stream. All right, let's see. Any other questions here? Let's see, where are we? All right, well, it is 9:30, so I'm gonna call it for this week. Once again, thank you to everybody, And, as always, like, I'm going to do my best to stick to this Wednesday at 8:30 live stream. So, you're all welcome to come back next week. But otherwise, I'll just say, thanks again and good night to everybody. Oh, hang on a second. Before I run away, Christina, wow. I was really just about to sign off, but wow, one of my former students. Chris, what year were you? You were like 2019? Were you 2019 your year? Is that when you graduated? Why do I feel like you were 2019? I don't know. It's like either 2018. I think you were 2019. Correct me if I'm wrong. But nice to see you, Chris. Yeah, so for anybody who's still here, Chris, I believe I taught you in physics and I taught you in AP calculus. Right, so that brings me way back. I do miss teaching physics, but your year was interesting because I was teaching physics out of license. So I was kind of winging it, but I mean, I had fun doing it. And, your class was really nice. I remember like a lot of you like passed the regents for physics. Like you all made me look good. So, I appreciate that for sure. But it's nice seeing you. Your year was, oh yeah, please. I'm so happy that I started doing these live streams because I'm trying to think who else from your year has stopped by so far, but a lot of my old crew has been coming back to say hello. And it's really nice because like my goal for the future is to kind of like merge like all the years that I've taught AP calculus. Like if the old generation could come back and help the new generation, I appreciate that. It was a lot of fun working with your class. So, like for sure. It was really like, a great year. And your class, I think, was like the last year right before I became a dad. So it was like probably my most carefree. I was definitely way more well rested then than I am now. But I will say, yeah, it was a lot of fun memories. I'm racking my brain. It's like putting me in the time machine. But we were all in North 214 at the time. So, yeah, so I'm still in the same spot. So, but very nice. Yeah, I'm glad you're doing well and stuff. I appreciate you stopping by. And, anyone like old students, you're always welcome to swing by the school. I know there's like a few things you have to do to like be able to get by, but, December time when your semester's up or something, or if you got free time, you're always welcome to swing by to the school, for sure. But yeah, so Chris, I'm doing these every Wednesday at 8:30, so you're always welcome to stop by to the stream to say hello as well. So thanks. And yeah, once again to everybody, signing